Welcome learners. In this video we are going to look at linear collisions and in particular elastic collision, and we shall begin by noting that momentum before collision is equals to momentum after collision, and also kinetic energy before collision is equal to kinetic energy after collision. Now here we have an example where we are given that an alpha particle of mass m alpha and speed v alpha strikes a stationary proton with mass mp. The collision is head-on and elastic, which means that they collide and move in different directions. Therefore, momentum and kinetic energy are both conserved. That is worth noting. Now, we are told that show that the speed of proton after collision is given by Vp is equals to 2m alpha over m alpha plus mp brackets multiplied by v alpha. Now, to solve this, we shall start by showing that momentum before collision is equals to momentum after collision. Now, here we have the mass. Momentum is a product of mass and velocity. Therefore, and we have two objects, that is the alpha particle and a stationary proton. Therefore, momentum before collision is equals to the mass of the alpha particle multiplied by the initial velocity of the alpha particle plus the mass of the proton multiplied by the initial velocity of the proton, which is equals to the momentum after collision. Now, since the velocity of the stationary proton is 0, because it is stationary, therefore, the product or the momentum before collision for the proton is 0. Therefore, we have m alpha v alpha initial, that is the momentum for the alpha particle, plus 0 is equals to momentum after collision for the alpha particle plus momentum after collision for the proton. And our equation now, or our equation 1, becomes m alpha v alpha initial is equals to m alpha v alpha final plus mp vp final. Therefore, if you put the like terms together, we have m, and then you factor out m alpha, we get m alpha is in brackets v alpha initial minus v alpha final is equals to mp vp final. Now that becomes our equation 2. And showing the relation for kinetic energy before is equals to kinetic energy after collision, we have a half m alpha v alpha initial squared plus a half mp vp initial squared is equals to a half m alpha v alpha final squared plus a half mp vp final squared. That is the kinetic energy for the alpha particle plus the kinetic energy for the proton before collision is equals to the kinetic energy for the alpha particle after collision plus the kinetic energy of the proton after collision. But since the kinetic energy for the proton, which was stationary, is 0, we have our equation as a half m alpha v alpha initial squared plus 0 is equals to, we factor out a half on that side, we get is equals to a half brackets m alpha v alpha final squared plus mp vp final squared. Now, since we have factored out a half and the other side you have a half, those two they cancel out, so we are left with the mass of the alpha particle times v alpha initial squared is equals to m alpha v alpha final squared plus MPVP final squared. Now, we can put the like terms together where we take M alpha V alpha final squared to the other side. We get, and then we factor out M alpha. We get M alpha V alpha initial squared minus V alpha final squared in brackets is equals to MPVP final squared, and that one becomes our equation 3. Now dividing equation 3 by equation 2, we get V alpha initial minus V alpha final is equals to VP final. That becomes our equation 4, and we can also make V alpha final to be our subject of the formula, which now gives us equation 5. That is, V alpha final is equals to VP final minus V alpha initial. Now, substituting equation 5 into equation 1, we get our equation 1 was M alpha V alpha initial is equals to M alpha. Now, where we have V alpha initial, we substitute with VPF minus V alpha initial, close the brackets, plus MPVP final. Now, this yields to M alpha V alpha initial is equals to M alpha VP final minus M alpha V alpha initial plus MPVP final. Now, taking the like terms together, we get 2M alpha V alpha initial is equals to, we factor out VP final, you have M alpha plus MP. Now, making VPF to be the subject of the formula, we get 2M alpha V alpha initial over M alpha plus MP. And we have our the final velocity for the proton is equal to 2M alpha over M alpha plus MP in brackets multiplied by V alpha initial. Hence, our equation is proven. Thank you for watching.